So if on the output side, if we get y1 of n with the same increment as x1 of n had, that it means that they have superimposed perfectly. Similarly with x2 of n, so this is the superposition. Sorry for writing x1 of n, that was by mistake. So now the next thing that we will learn is decomposition and synthesis. So DSP basically is the decomposition of signals and then recomposing them or their synthesis in to newer, more uh, uh, organized and well-toned signals. So what is decomposition? Decomposition is breaking down a complex substance or signals in the case of DSP, and synthesis is referring to merging different signals to make a unit. Now, what types of decomposition do we have? I will discuss some of them very briefly. Impulse decomposition. Impulse decomposition, the signal is broken into spikes because it's an impulse signal, and only there is a magnitude of 1 at 0. This is the basic definition of impulse, so that's why hence it is called impulse decomposition. The otherwise it has zero, otherwise it acts as a zero signal. Now the second thing that we have is step decomposition. Signal is broken into spikes. For example, if we have this signal, we have a -1, we have a magnitude of 1 at -1 and -1 at -2, and these 1 magnitude of 1 at 1 and at 3 we have also magnitude of 1. We can decompose them into steps or spikes. These are individual spikes, and if we merge them together, then they will become a single signal. So if we merge them together after performing some operations on them, then we'll get our step decomposition and synthesis. The next thing is even decomposition and odd decomposition. Now in even decomposition we have this formula over here, where E of n is equal to x of n and x of n plus the reflected version of x of n divided by 2. So here we consider x of t, we consider a continuous signal for this example, rather than a digital signal, although the same rules can be applied to digital as well. तो अगर हम देखें कि इस सिग्नल में there is a rectangle at 1 to 0, then there is an elevation from 0 to 1, then there is also a rectangle shape at from 1 to 2. So if we mirror this signal, we know from the previous lecture then how to do that. Here we have -2, -1, we have a rectangle like shape at this point, and then we have a inclination, then again a rectangle from 0 to 1. So how we will add them? If we add this area from -2 to -1, we have nothing over here but elevation of 1 over here. This is 1. So what we will do, we'll divide it by 2, so it will be 0.5. This is 0.5. This is 1. So here we have half of that. Now a rectangle plus an inclination, so it will be incremented by 0.5 because we'll half it also, so it will become something like this. And now on the other side we have a declination and a rectangle shape. When we'll add it, it will be increased by amount of 1, then we'll half the signal. So this is the resultant right here, and then the same for this. From 1 to 2 we have nothing, and for here we have one block, we'll half it. This will be 0.5. This is 0.5 on the y-axis. This is an even decomposition because we have the same signal mirrored. on the other side of the axis. For odd decomposition we have this particular formula. If we perform this operation, we'll get on this signal, we'll get this type of resultant signal. Now for the recognition of odd decomposition, it is the negative inverse, negative mirror. So you can see that this is mirrored as well as inverted on the other axis. उसके बाद हमारे पास आ जाता है फोरियर डिकम्पोजिशन. फोरियर डिकम्पोजिशन, कम्प्लेक्स सिग्नल इज डिकम्पोज इनटू बेसिक साइनोसाइड्स. हमें इसमें हम इसको साइनोसाइड्स में डिकम्पोज करते हैं यूजिंग अ सर्कल लाइक दिस. Now if our signal is being decomposed, there is an implication that the system should be linear. Although if there are minor disturbances, minor noises in the signal, these can be neglected. For example, x and y are being convoluted. If we take the log of these both of these signals, then if there are any minor disturbances in the signal, these can be roughed out. That's it for this lecture. We'll see you next time in our next lecture. Thank you very much.